Good morning. Yes. Good morning, everyone. I'm Stephanie, and today I'm going to talk about the flow pattern north of Taiwan and the migration of the Kuroshio. So the northern shelf of Taiwan is a highly dynamic oceanic region. The Kuroshio current flows along Taiwan's east coast and frequently intrudes onto the northern shelf. At the same time, the water from the Taiwan Strait goes northward and interacting with the Kuroshio intrusion, and forming a complex circulation system here. But how important is the Kuroshio? The Kuroshio plays a big role in East Asia. It is a powerful warm current flowing from the tropics to the north and bringing heat that helps the places like Taiwan, Japan, and eastern South Korea warmer in the winter. And this also help farming and also lower the energy use. And when the Kuroshio meets the cold Oyasho current near Japan, it creates super productive fishing zones, attracting fish like mackerel, skipjack, and tunas. And these areas are vital to the fishing industries of Taiwan and Japan. And the Kuroshio, it is very steady. It has very steady flow. It's also matter to shipping. So when we know where it goes, it can help ships save time and fuel, and also stay safe. And we know that Kuroshio is so warm, depends on our ocean, and it can make the typhoon stronger. So that's why the weather agencies watch it closely to improve typhoon forecasts. And before some past studies, we have already known there's a codon on the northern shelf of Taiwan. So let me tell you something about the codons. So let's see, codon is a counterclockwise circulation that goes this way, and you can just imagine that it's a typhoon in the ocean. So everyone can use your right hand and just do some up gesture and like counterclockwise and up. So codon can bring upwelling, and upwelling can bring cold water to the surface. So how important is the upwelling? Upwelling has a major impact on ecosystems and climate. It brings nutrient-rich deep water to the surface, boosting phytoplankton growth and supporting the entire marine food web. And many key global fishing zones exist because of upwelling, and making it vital to the world's fish supply. And the upwelling also play a role in global carbon cycle, by helping phytoplankton absorb carbon dioxide and store carbon in the deep ocean, potentially slow global warming. Furthermore, upwelling also influences coastal climates. It often cooling the temperatures and reducing rainfall. Okay. So in this study, we aim to know the seasonal variation of mesoscale flow patterns north of Taiwan and the relation to the migrations of the Kuroshio, and also the interaction between the intruding Kuroshio and the Taiwan Strait outflow. So to investigate these patterns, we analyzed historical oceanographic data from 1985 to 1997 from ocean data bank, including CTD and ADCP archives used to analyze current profiles. And we also use infrared satellite images from NOAA. We use it to analyze sea surface temperature patterns and identify the glacial intrusion, cold domes, and thermofronts. We also collect the mooring data from July 1992 to March 1994, located on eastern side of the North Mianhua Canyon. And this mooring included an ADCP to measure current velocity, and an CTT to record salinity, temperature, and depths. Additionally, we conduct 3 research cruises. Cruise A was conducted in summer, while Cruise B and C were conducted in winter. These 3 cruises provided to snapshot ADCP velocity measurements, and these 3 pictures are their cruise routes. So let's talk about seasonal migration of the Kulosho. So in these 2 current velocity profile figures, we can see this kind of color, and the warm colors means flow to the north, and the the cool colors means flow to the south. So we know that Kulosho is a strong northward flow current. Yeah. So we can see this warm colored area and this warm colored area are Kuloshos. Kulosho, not this. Kulosho. So it is clear that the Kulosho is further away from the coast in summer and closer to the coast in the winter. And this seasonal migration can obviously impact the flow pattern north of Taiwan. And here we see the flow pattern north of Taiwan and the sea surface temperature. The arrays in the figure represent the velocity and direction of the flow. And the background color means the sea surface temperature. So we can see here, oh my gosh. The current, the Kulosho splits into a northeastward flow and a northwestward flow, respectively. And this figure also reveals the phenomenon of cold dome. And we can not only see the counterclockwise flow pattern, but also the relatively cooler water in the cold dome. So we also can see the Taiwan Strait outflow here is blocked by the cold dome. So the water will not going onto the northern shelf of Taiwan. And you can see these cold domes, their locations are not steady. And here in winter, we can see a completely different situation of the ocean current. Like we don't see any cold domes here, and we can thus the Taiwan Strait outflow can just go onto the northern shelf of Taiwan and joins the Kulosho and creates a really strong northward flow. Additionally, in additional to seasonal migration, we also discovered intra-seasonal migration. So here is a figure shows the long-term current profile of the Kulosho, and here means go eastward and let's go westward. So in this figure, the Kulosho is mostly go eastward in the upper 100 meters depths, but fluctuates below these depths. And in summer, we can see here is a strong westward appears, and in winter it's mostly westward, but occasional eastward current suggestion the short-term intra-seasonal migration of the colossal position. And here we can see we can find that the colossal current also has intra-seasonal variations. And here this figure shows the relationship between temperature, salinity, and U vector at 190 meters over time. So we can see the temperature and salinity has a very strong similar fluctuation with U vector. And when the colossal move westward, like eastward, like here, the temperature and salinity increase, and otherwise the water become cold and fresh. So this figure further improves intra-seasonal variations. And here we notice that the absence of the counterclockwise circulation could be related to its own intra-seasonal migration. So let's summarize. In summer, the colossal migration goes offshore, and the colossal splits into two flows, and the surface colossal water onto the northern shelf by cold domes, like go there and yes. And in winter, the colossal gets closer to the shelf, and the Taiwan Strait outflow joins the colossal and make it northward. And there's some takeaways from this study. Number one, the colossal migration significantly impacts mesoscale flow pattern north of Taiwan. And
I think your presentation is perfect. You speak fluently, and you use different colors to emphasize the key point in your sentence, and your sentence is short enough to quickly point out the key points. Yes. And your images were large enough to show the key point. Yeah. Thank you.
I think your PPT is easy to read, and your presentation is really good. But the time should be controlled, you know? But in summary, it's a great presentation also. Thank you.
You put more information and do more explanation about the codoms and more than the last time, and I think it's great. Your pronounce is good, but I think it's just need more fluent. Yes, and your explanation and your figures are easy to know. Yes, and it's a great presentation.